right, so for this problem, what we're asked to do is find all the points that are on either the y or the x-axis, it's two different problems, from these two red points, from negative 5, 0 and from 1, 0. So the first one is asking, let's say, all the points that this distance here, from negative 5, 0 to some point on the y-axis. I don't know what it is, so I've called it 0, comma y, because I know the x-coordinate of any point on the y-axis is 0. So I want this distance to be twice that distance. What I'm going to do is illustrate that. So there's the first distance, there's the second distance. When we're dealing with a whole bunch of unknowns, it's good to label things. So I'm going to label this D1, this D2. You can really label them anything you want as long as it makes sense to you and it's clear. So what we need to do now is look at what we're asked to compare. So we want all the things that are from this point over here to be twice the distance from this point, aka D1 must be twice the distance of D2. So what I'm going to do is write that, because that's where we're going to start. D1 is twice the distance of D2. So here I've written the two distance formulas. We've got the x2 minus x1, so a 0 minus a negative 5. We've got the y2 minus y1, so we've got y minus 0. And likewise over here. And don't forget this too, this is very important. So the next step in my in algebra here, so what I'm trying to do is solve for y, that's my only unknown. So I'm going to square both sides. Now remember, you've got to square everything. The reason I'm doing this is because I want to get rid of these radicals here, because doing algebra with radicals is not the most fun thing in the world. So let's go through and square everything. So that's going to look like this. Now, remember, it's really easy to forget to square this 2 here, and you definitely don't want to forget these parentheses. Remember, there's always these secret parentheses under a radical. Don't forget about them, okay? So that 2 squared still needs to get multiplied by everything else. Then we're going to just do some algebra, and we're going to come up with our answer. So after some steps, we get to here, where 7 is equal to y squared. Now on this last step, it's easy to make a mistake, so don't fall for it, but we're going to square root both sides. And when you square root, remember, don't forget the plus or minus. So there's actually 2 values here, which should make sense, right? Because couldn't I put this point down here, and wouldn't that make sense with my distances? Yeah, I think it would. So there's 2 solutions to this. Now remember, we still don't have the coordinates, so I would say that we should write 0, comma root 7 and 0, comma negative root 7 as our solutions. So those are the 2 points that are twice the distance from negative 5, 0 as they are from 1, 0 that are on the y-axis. So now let's look at our x-axis points. Okay, so now I've reset up the problem for our green distances now, the ones along the x-axis. And this one might be a little easier anyway to kind of guess on your own without having to do an equation. But I want to do it the same way we did the previous one just so we can see the cool connections we can make. So I have already my equation D1 equals D2. That's going to be the same thing as before, as long as you label it the same way I did, right? We want the distance from negative 5, 0 to our point to be twice what this distance is. So it's important that you have the 2 in the right place. So what I'm going to do is set up our distance equations. Okay, so there we are. And again, don't forget that 2 in there. Right here. Also remember, or I guess let's notice, this is going to be a nice easy equation for us because we've got a lot of zeros. So let's go through and do some algebra to solve for x. And remember, my first step, just like last time, is going to be to square everything. So let's go through and do that. So here's some algebra. Now it's going to be very tempting to square root at this step, but I would urge you not to, because remember, when you square root, you have to do plus or minus, and doing plus or minus here would get very confusing. So let's expand, aka FOIL, these terms. Don't forget that 4 needs to get multiplied by everything after you FOIL, all right? So then we're going to get these nice expanded values. Combine all the terms. Now remember, there's a squared in here, right? So whenever we see a quadratic like that, our goal is to set it equal to 0, right? So get everything on one side, and there's one step further I could do to simplify this. If you notice, every term can be divided by 3, so let's do that. And there we go, we've got a nice equation. Now remember, the way that we solve these so far in this class is by graphing, And since we want the values that make y equal to 0, we're going to find those x-intercepts. So after you put this in your graphing calculator, you're going to get something that looks like this. So this is one of those U-shaped parabolas. And remember, we want the x-intercepts. Those are going to be our solutions. So it looks like we get two solutions here, -1 and 7 for our x values. And if we look at our diagram, I guess that could make sense, right? Couldn't there be another point out here that also works at 7, 0? And then we've got our point here that's actually going to be -1, 0. So just like the previous problem with the y-axis points, there are two solutions on the x as well. And that might not be as intuitive because it's not as symmetrical as the nice y points were. So great problem. We got to practice distance formula, and we got to practice solving quadratics by graphing. So enjoy.